Welcome to the General Chemistry 2 class. This section is on physical properties of solutions. This lesson is about the colligative properties of electrolyte solutions. Let's begin. In this lesson, we will differentiate the colligative properties of non-electrolyte solutions and electrolyte solutions. Recall the colligative properties are properties of solution that depend on solute concentration. These properties are vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Recall that electrolytes are solutes that undergo dissociation in water. Strong electrolytes dissociates completely, while weak electrolytes dissociates partially. Considered 0.01 molal aqueous potassium chloride solution. The solute produces 0.01 molal potassium ion and 0.01 molal chloride ion in water. Thus, the solution has a total ion concentration of 0.02 molal. In effect, the colligative properties of this solution are twice as much as those of a 0.01 molal solution of a non-electrolyte like glucose. To account for the number of particles released by a given amount of electrolyte, a factor called the Van 't Hoff factor, or I, is used as a multiplier in the calculation of colligative properties. I equals actual number of particles in solution divided by the number of formula units of electrolyte initially present in solution. For non-electrolytes, I equals 1 since these compounds do not dissociate in water. For electrolytes, the expected Van 't Hoff factor is equal to the total number of ions per unit of compound. Examples are shown on the table. The actual Van 't Hoff factor is slightly lower than the expected value. This can be explained by the formation of ion pairs in solution. An ion pair is an aggregate of ions of opposite charges in a solution that are attracted to one another by electrostatic forces. The actual values of Van 't Hoff factor can be measured experimentally. To account for the dissociation of electrolytes, the equation for calculating colligative properties of electrolytes are modified by incorporating the Van 't Hoff factor, as shown on the rightmost column of the table. By looking at the tabulate equations, we see the colligative properties increase with the increasing value of Van 't Hoff factor, assuming that solute concentration is held constant. Consider aqueous solution of ethylene glycol, potassium bromide, sodium sulfide, and aluminum nitrate, whose concentrations are 0.01 molal. Since ethylene glycol is a non-electrolyte, I equals 1, thus it has the lowest colligative properties. On the other hand, aluminum nitrate has on the other hand, aluminum nitrate has I equals 4. So, its colligative properties are the highest among the given solutions. The colligative properties of electrolyte solutions take into account the number of ions produced when an electrolyte dissociates into ions. With this, the Van Hoff factor is incorporated in the equations for calculating the colligative properties. To learn more about this lesson, kindly visit the references. That's all for this lesson. Thank you.